This is Graphing Parabolas Part 3. I just want to review something with you before we put everything together. The standard form of a parabola is y equals a times quantity x minus h squared plus k. This is the form we want the parabola in to be able to name the vertex. If you can name the vertex, that leads directly to the axis of symmetry. And then we'll be able to do the graph, as I'm going to show you in just a few minutes here. But this is the form we would like the equation in. We can put together everything we learned in the previous two videos. Here's our equation. It's almost in the correct form. You might want to put a little plus 0 here to help you out. The first thing we need to name is the vertex, and the vertex comes from inside the parenthesis, changing the sign, so it's -1, comma 0, because there's nothing after the x squared. That's going to help us do a couple things. It's going to lead directly to the axis of symmetry, which is x equals -1. Also, to do the graph, we need to pick points on either side of the vertex. Let's go ahead and graph -1, 0. Sometimes it's easier to find a point here and a point there. The point immediately to the left of -1 is -2. The point immediately to the right of -1 is 0. These are the 2 points we're going to plug in for x and do the arithmetic so that we can graph the rest of the parabola. So if you put -2 in for x, -2 plus 1 is -1, -1 squared is just 1, plus 0 is 1. Because this is symmetrical, when I put 0 in, I ought to get 1. So you could take a chance and just assume it's 1 or do the arithmetic. Put 0 in here. 0 plus 1 is 1. 1 squared is 1. So that does verify we did the math correctly on this number up here. So -2, 1, over 0, up 1, and then draw the parabola. Nice little curve. It's kind of hard for me to draw it with this tool I have, but that's about what the parabola looks like. Now we can tell from the graph, or we can tell from the equation, that it opened up. We've said earlier the domain is always just -infinity, infinity, both with the parentheses rather than the brackets. The range refers to the y values. The smallest y value here we have a 0, and it goes up to infinity with a square bracket here and a parenthesis there. Next example, let's get the vertex. The vertex is the key to being able to do a lot of this work. The vertex here is what's inside the parenthesis with a sign change, -3, -1, which leads directly to the axis of symmetry, x equals -3. Based on that right there being a negative, I know this is going to open down. We'll see if the way we graph it verifies that. I can name the domain before I do anything else. -infinity to infinity. Let's wait on the range till we get our graph done. So the vertex is -3, -1. That's our first point. The x value immediately to the left of -3 is -4. The x value immediately to the right is over here, which is -2. So we need to do the arithmetic on those values. Put -4 in here. -4 plus 3 is -1. -1 squared is 1, but there's still a negative hanging out front. Minus that 1 is going to give us -2. Let's verify that that's correct by doing the arithmetic here. -2 plus 3 is 1. 1 squared is 1 with a negative in front, and there we go. We've got -1 minus 1 is -2. So all I need to do is graph those 2 points. -4, -2 is here. -2, -2 is there. And my curve is going to face down and look about like that. All right, the vertex inside the parenthesis is going to be a -2 followed by a -1. Gives me an axis of symmetry of x equals -2. Because this is positive, it opens up. The domain is our usual, -infinity, infinity. Let's graph that -2, -1. We need to pick the x value immediately to the left of that, which would be -3, and pick the x value immediately to the right of that, which is -1. Let's do this arithmetic. Put -3 in here. -3 plus 2 is -1, but -1 squared is 1. 1/2 times 1 is a half. 1/2 minus 1 is -1/2. And incidentally, you can do all of this arithmetic on your calculator. So we get that for our y value. Let's check out this value. Put -1 in for x. -1 plus 2 is a positive 1. 1 squared is 1. So 1/2 times 1 is a half, minus 1 gives me -1/2. If the arithmetic trips you up, plug it in the calculator rather than trying to do it by hand. But notice something. no matter what we put in here, this right here is going to work out to be 1 because we have chosen our x value to be 1 step away in either direction. So all of this right here has to be 1. So all you have to really do is 1/2 times 1, take away 1. That makes the arithmetic a little bit easier for you. Let's graph these points. -3, -1/2 is just down halfway. -1 down 1/2. And those are going to be my points that I'll try to draw the curve. And notice that this is just a little bit fatter. I missed the point, but it's hard for me to graph with this tool. But it is fatter. We established that in the last video. When this is a fraction, our parabola will be a little bit fatter. The range refers to our least y value, which is -1, and that goes to infinity with a bracket here and a curve here. I wanted to look at this again just from the arithmetic standpoint. Our vertex on this is 4, 3, so that when we pick our t-chart values, you pick the number immediately less than 4, which is 3. Pick the number on the other side of 4, which is 5. These are the values that we are going to plug into this equation. But because we have chosen these numbers so that they are spaced 1 away, when we plug either 3 or 5 into here and do this part, including the square part, this just turns into 1. 3 minus 4 is -1. -1 squared is a +1. Put a 5 in there. 5 minus 4 is 1. 1 squared is 1. So that the arithmetic doesn't have to be very difficult. It just works out to be -2 times 1 plus 3. I can make that even easier for you. If this is always a 1, then -2 times 1 is just this number. All we really have to do is that plus that. -2 plus 3 gives us a +1 for each of those. So the vertex would be the point I graph first, and then those two.